Now we will be looking at solving inequalities. Same idea as solving equalities, however, with some exceptions. So the first one is pretty straightforward. It's what number minus 2 is least or equal to 7. You could just readily see that what number minus 2 gives me 7. So 9 is your answer. My variable is x, and it's the same symbol. If you can't do this in your head, you do the inverse operation, which is you would add 2 to each side of the inequality to keep it balanced. So that would give me x, and here that would give me 9, and there would be no change on the inequality symbol. Here, however, this is quite an interesting question because negative 4 times what number gives me 12? Well, you could probably do that in your head, and the answer would be negative 3, and we know x is the variable. However, here, because we actually divided, because to solve this question here, you have to divide by negative 4. And because we're divided by a negative here, you have to flip the symbol. Now, the rationale from this is you could have done this differently. You could have added 4x to each side of the inequality to have 0 here and then subtract 12. And then that's why the inequality ends up being flipped. So this would be your answer here. Be careful with this one. If there's a negative coefficient in front of your variable, in the end, when you solve, you will have your sign will be flipped or inversed. Here, you want to solve this question, so there's a negative coefficient in front of your variable, your sign will be flipped. So you might be able to do this in your head, but if you can't, you would do negative 4 here, just to isolate your x variable is greater than 2, and then you know your answer is going to be negative 1 because negative 2 times what gives me 2. It's negative 1, but because to solve here you have to divide by negative 2 to get negative 1 as an answer here, you have to flip your symbol. So x would be smaller than negative 1. All right, let's take a look at 3 more examples. Same idea for this one. However, here we have a positive coefficient, so we don't need to worry about affecting the symbol at all. I would just negative 6 on each side, and then I would have 3 times what number gives me 6. If you can't do that in your head, hopefully you can, but it's 2. 3 times 2 gives me 6. But again, how do you get 6 using these two numbers is you would divide by 3. And that's how you isolate x here to have 1x equals, not equals, greater than 2. Here, this one here, you would subtract 16 to each side of your inequality, which would give me negative 10 greater or equal to, this would give me 0, so just 2x. Now, 2 times what number gives me negative 10 is negative 5. Here I wouldn't need to flip the symbol because I have a positive coefficient for my variable. So just negative 5 is less than or equal than x. So, but this is the same as some people have preferred to have it written this way, just so they have their variable on the left side. But I mean, if you're saying the same thing, these two things are the same expression. Now the last one here, you do have a negative coefficient here. It's negative 1. So we will have, in the end, have to flip the symbol. So you will do plus 5 first operation to isolate negative x, or negative 1x if you wish, is greater than 8. Now this is the same as this. So how do you get there is that you multiply by negative 1 on each side. You could do that, or you could divide by negative 1. It's the same idea, but it's just two here. When you multiply two negative numbers, you're going to get your positive x. So be careful when you're solving. If you ever have to multiply or divide by a negative number, like here, this example here, this example here, and this example here, you will have to flip the symbol on each case.